Hello everyone, myself Mrs. Janvi Darshan Raut, lecturer in Electronics and Telecommunication Department of Pravin Patil College of Diploma Engineering and Technology. In this video, we are going to learn about our next topic of digital communication system and coding, that is entropy, information rate, channel capacity, Hartley's law, Shannon-Hartley's theorems. Now, first we will start with entropy. What is entropy? The entropy is defined as the average information per message. It is denoted by H and its units are bits per message. The entropy must be as high as possible in order to ensure maximum transfer of information. We will prove that the entropy depends only on the probabilities of the symbols that are being produced by the source. Now, next is channel capacity. Channel capacity represents the maximum rate at which data can be transferred between two points in the system with an arbitrarily small probability of error. The unit for channel capacity is bits per second, and the channel capacity can be summarized as C is equal to R max bits per second. As we know, a transmission channel is a medium over which the electrical signals from a transmitter travel to the receiver. The two important characteristics of these transmission channels are signal to noise ratio SNR and second is bandwidth. Now, what is Hartley's law? Statement for this Hartley's law is the amount of information that can be sent in a given transmission is dependent on the bandwidth of communication channel and the duration of transmission. In other way, Hartley's theorem states that if the bandwidth of transmission line B transmission channel is B, which carries a signal having L number of levels, then the maximum data rate R on this channel is given by R is equal to 2B log to L. The number of levels L can be 2 or more. According to Hartley's law, we can transmit more information in a given time by increasing the bandwidth of a channel. With reduced bandwidth, it will take longer time to transmit the same information. Now next is Shannon's theorem, or you can say Shannon's-Hartley's theorem. Shannon's-Hartley's theorem can be defined as the statement of the Shannon's theorem is given that a source of m equally likely messages with m greater than 1 which is generating information at a rate r, given that a channel of capacity C exists, then if r is less than equal to C, then there exists a coding technique such that the output of the source may be transmitted over the channel with a probability of error in the received message which may be made arbitrarily small. Meaning, the theorem is concerned with the rate of transmission of information R over a communication channel. The channel capacity C is a rate of transmission in bits per second. According to the theorem, for R less than equal to C, transmission can be accomplished with coding without error in the presence of noise. There is a negative statement associated with the Shannon's theorem. Its statement is as follows. The Shannon's theorem states that The channel capacity C, meaning the theoretical highest upper bound on the information rate of data that can be communicated at an arbitrarily low error rate using an average received signal power through an analog communication channel subject to adaptive while Gaussian noise of power. Or, in simple way, this theorem is complementary to the Shannon's theorem. It applies to a channel in which the noise is Gaussian. The channel capacity of a wide band limited Gaussian channel is given by C is equal to B log to 1 plus Sn beats per second, where B is the channel bandwidth, S is the signal power, and N is the noise within the channel bandwidth. S slash N is known as signal to noise ratio or the carrier to noise ratio of the communication signal to the noise and interference at the receiver. Next is information rate. If the source of message generates R number of messages per second, then the information rate is given as capital R is equal to small r into h, where small r is equal to number of messages per second and h is average information. Next is source coding. In source coding, the encoder converts the digital input signal into another digital signal. Source coding is used to reduce or eliminate redundancy because doing this will ensure an efficient representation of source output. Following are the examples of source encoding techniques. First is PCM, DM, and Huffman coding. In computer, source code is any collection of code with or without comments written using a Huffman readable programming language, usually as plain text. The source code is often transformed by an assembler or compiler into binary machine code that can be executed by the computer. Now, this is the simple block diagram of source coding, which is having two blocks: discrete memory less source and source encoder, where sk is the output of the discrete memory less source and bk is the output of source encoder, which is represented by zeros and ones. The encoded sequence is such that it is conveniently decoded at the receiver. Now, requirement for an efficient source encoder: the encoder should produce the code word in the binary form. It should be possible to decode the source encoder uniquely so as to reconstruct the original source sequence perfectly from the encoded binary sequence. Thank you.